Science Made Simple with Mr. Sani.
Let us look at what is meant by motion. Motion is the change in position of a body. Change in position of a body. That is the movement of a body. Motion is the movement of a body. That is, when you apply force to an object, you change the motion of that body from the original position. That's why I say motion is the change in position of a body. According to the Newton's first law of motion, which states that every object will be in a state of rest or at a uniform velocity unless it is being acted upon by an external force. That is, if you place a stone on a table, we expect that stone to be on that table in the next 100 years if nothing pick it or if nothing happens to it. So that is the first of. To change the position of that stone, that means you must apply force directly or indirectly. If you apply the force directly, that is contact force. Indirectly is gravitational force. That is, when there is contact between your hand and the stone, that is contact force. But if there is no contact, we have non-contact force. Motion, in essence, you see that force cause motion. Before a body can change position, we must apply force directly or indirectly. We have two types of force. We have the contact force and the non-contact force. Contact force and non-contact force. Non-contact force or field force. We call the non-contact force as field force. So contact force can be either by pull in different direction, push in the same direction with the force, or frictional force. These are contact force. That is, there must be contact between the two bodies. While the field force, you don't need contact between the two bodies before you experience that type of force. Here we have the gravitational force. That's the pull of the earth. Magnetic force. Magnetic force and electric force. Now, motion, we have different types of motion. We have different types of motion. These are translational motion. Translational motion. One, translational motion. Translational motion. Two, random motion. Three, rotational motion. Four, oscillatory motion. And we also have relative motion. Translational motion. This is the motion of a body in specified direction. That is, we can say the motion of a body in a straight line when you can easily define the direction. That is the motion of a body in a straight line. the straight line motion, line. Random motion, this zigzag motion, that is no specific direction, no specified direction. It can move as any direction, like the motion of a butterfly. We say zigzag direction, regular direction, not defined. Rotational motion, that's the motion of the body in a circular form, circular motion, that is having a fixed center, circular motion of the body. Oscillatory motion, that is the to and fro motion of the body, moving up and down, moving from one fixed point to another and come back to the rest position, move to another fixed point. That is to and fro movement of a body. As you can see in our pendulum clock, aago ẹlẹ́pọ̀n. While relative motion is the motion of a body relative to a particular reference point, that is when two bodies are in motion, you relate it to each other. That is, maybe one body is stationary, the other one is moving. The movement of that body relative to the stationary body, that is what meant by the relative motion, relative to one reference point. Now, we want to look at speed. What do you mean by speed? Speed is defined as the rate of distance with time. That is distance over time. That is the movement of a body with time, the rate of distance with time. Speed is measured by speedometer. That is what we have in our motor. We have speedometer in our motor. So that speedometer is measuring our speed. That is how the motor how fast the motor car move or how slow. That is speed. Speed is distance over time. Speed is a scalar quantity because distance is also a scalar quantity. We also have velocity. Velocity is defined as the rate of change of displacement with time. Speed, distance with time. The velocity is displacement with time. Speed and distance, scalar quantity. Velocity and displacement, they have vector quantity because they have both magnitude and direction. Now, to calculate the speed, the unit for the speed, distance we have meter, displacement we have second. So bring everything on the side, it will be meter per second. That is, the speed is meter per second. But in our usual daily activities, when our motor is going, we usually calculate the distance in kilometer while the time is in hour. You check your speedometer in your car, you see that one is calibrated in kilometer per hour. Kilometer per hour. So in our speedometer we have kilometer per hour. Our speed, the formula the unit of speed is also kilometer per hour. You can convert from kilometer per hour to meter per second, or from meter per second to kilometer per hour. Depends on the question. Now, displacement. We say displacement is distance in a specified direction. Displacement is also in meter. since it's distance in a space in meter all over s time in second. The unit for displacement is also meter per second. You can see that both speed and velocity, they are somehow interwoven. They have the same unit. We can easily calculate meter per second and meter per second here. We can calculate whatever we get from meter per second to kilometer per hour or vice versa. The speed is a scalar quantity because it has only magnitude, while velocity is vector quantity. Now we want to do some calculations in connection with this formula. Let me teach you how to convert from kilometer per hour to meter per second. Let's say we have 100 kilometer per hour. We want to convert it to meter per second. How many meter make 1 kilometer? We have our 1000 meter is equal to 1 kilometer. 1000 meter is equal to 1 kilometer. How many seconds make 1 hour? We have 60 seconds to be 1 minute. How many seconds make 1 hour? 1 minute, 1 hour. 1 hour is 60 minutes. Since 60 seconds make 1 minute, how many seconds make 1 hour? It will now be 60 times 60 seconds. 60 times 60 seconds is equal to 3600 seconds. That is, our 1 hour is equal to 3600 seconds. Our 1000 meter is equal to 1 kilometer. So to make 100 kilometer per hour to meters per second, it now be 100 kilometer per hour. It now be 100. This kilometer, this K is 1000 meter. K represent 1000 meter per hour. You know, if I say 100 kilometer, 100 kilometer per hour. If the h minus 1 here comes down, it will be division line 100 kilometer per hour. That means the hour will come down. It will be divided by how many seconds make 1 hour? 3600. So you now cross it. So it will be 1000 divided by 36. Whatever you get is the answer. So you can easily convert from kilometer per hour. What you just need in essence is multiply the value by 1000 and divide it by 3600. 10 kilometer per hour is equal to 10 times 1000 divided by 3600. 20 kilometer per hour will be 20 times 1000 divided by 3600. 200 kilometer per hour will be 200 times 1000 divided by 3600. The value you get for all this one will now be meter per seconds. Meter per seconds. meter per second. Meter per second. So that's how to convert from kilometer per hour to meter per second. A car cover a distance of 10 kilometer in 50 seconds. Calculate the speed of the car. I want to understand the question very well. You write out the given values. From the question, we have the distance to be 10 kilometer. That is, our distance is 10 kilometer from the question. In 50 seconds, that is 50 seconds represent time. Time is 50 seconds. If you look at this question very well, 10 kilometer, we have to convert it to meter. 10 kilometer to meter will be 10 times 1000. That K stands for 1000. It will now be 10,000 meter. Or if you don't know it in that method, you can say 1000 meter is equal to 1 kilometer. Our S in meter is 10 kilometer. Now we want to calculate the S in meter for 10 kilometer. We cross multiply like this. This will give us 1000 times 10 is equal to S times 1. That is 10,000 is equal to S meter. That is, our S will now be 10,000 meter. So what I'm saying is that our 10 kilometer is equal to 10,000 meter. And calculate the speed. We are asked to calculate the speed from the question. Under our given value, say from the question we have our distance to be 10 kilometer, our time to be 50 seconds, and we are asked to calculate the value. You put question mark on the value that we are to calculate. That is, our speed, which we are asked to calculate, will be is distance over time. Our speed, the formula for calculating speed is distance over time. From the question, our distance now is now 10,000 meter. Our time, that one is already in standard unit, 50 seconds. We now cross it. That be 200. That be our is equal to 200 meter per seconds. The speed is 200 meter per seconds. Example 2. A train moves with a speed of 54 kilometer per hour for 1/4 minute. Find the distance traveled by the train. From the question, we are given, no, I said you should start with giving that. These are the information from the question. We are given our speed to be 54 kilometer per hour for 1/4 minute. Our time to be 1/4 minutes. Find the distance by the train. Then distance is what we are looking for. Question mark. These are the information supplied by the question. Now, speed is given in 54 kilometer per hour. 54 kilometer. So we have to convert That 54 kilometer per hour to meter per second. 54 kilometer per hour is equal to 54 times 1000 divided by 3600. Here we have P. That's the 540 over 36 meter per second. So that is 15 meter per second. So instead of us having 54 kilometer per hour here, we say that our 54 kilometer per hour is 15 meter per second. Then our 1/4 minute, that is 1/4 of 1 minute. 1 minute is the same thing as saying 60 seconds. 1 minute is equal to 60 seconds. So 1/4 of a minute will now be 1/4 of 60 seconds. That will be what? 15 seconds. So our 1/4 minute will now be 15 seconds. Now we have converted speed to 15 meter per second and time to 15 seconds. Then from the formula for speed, we have speed is equal to distance over time. Now we have to calculate distance. We can make distance the subject of the formula. Distance will now be speed times time. You cross multiply 5. So distance, our speed distance is what we are looking for. Our distance will now be speed. Our speed is 15 meter per second and our time is 15 seconds. Our distance will now be 15 times 15 is equal to 225 meter. That's it. Yeah, we are doing that. With time. The acceleration of the body is the rate of change in velocity with time. So when we say change in velocity is equal to final velocity minus initial velocity. So final velocity is denoted by v, while the initial velocity is denoted by u. So our acceleration a is now v minus u over time. That is, our acceleration is equal to initial velocity minus final velocity minus initial velocity with time. Acceleration is v minus u over time. The unit for acceleration, change in velocity is unit for velocity meter per second. Unit for time is meter per second. So our acceleration is meter per second squared or meter per second squared, like this. That's the unit of acceleration. Velocity is meter per second. Time is seconds. So it's going to be meter per second squared. From here, our acceleration will cross multiply. It will be at is equal to v minus u. Or you say v minus u is equal to at. Our v here will now be u plus at. t. From here, this formula is called first equation of motion. The opposite of acceleration is what we call deceleration. Deceleration, that is the opposite of acceleration. We have our acceleration to be a, deceleration is minus a. That is opposite of a. So whenever you see negative sign, if this one is 5 meter per second square and this one is minus 5 meter per second square, that minus is indicating deceleration. Whenever you see minus, you know that it's deceleration you are talking about, which is the opposite of acceleration. Other equation of motion, we have our s is equal to ut plus half at square. That is the second equation. The third equation is v square is equal to u square plus 2as. That is third. All these three equations, they are called equation of motion. The first equation of motion is v is equal to u plus at from this formula. The second one is s, that is s is the distance. S is distance. Is equal to ut plus half at square. Ut plus half at. U is the initial velocity. T is the time. A is the acceleration. T is the time. Third equation of motion is v square is equal to u square plus 2as. That v is the final velocity square is equal to initial velocity square plus 2 acceleration times distance. Okay. Let me quickly explain the meaning of distance time graph. From the name distance time graph, that means you have your distance in your y-axis and the time in x-axis. This place is distance. In physics, there is nothing like y or x-axis. You can only use y and x-axis in mathematics, but you make use of the quantity, distance axis and time axis. Distance axis and time axis. So our distance time graph means that our distance is in this direction, vertical direction, and our time is in horizontal direction. So whatever we get when we draw distance against time, the rate of change of position with time, we draw it, maybe get a straight line graph like this. We calculate the slope of the graph. The slope is by making the graph a right angle triangle like this, and this place represents the slope. So the value from here to here is distance. The value from here to here is time. And from tan theta is equal to distance over time. So when you are calculating distance over time, that is the slope of the graph. That is the slope of the graph, which is also tan theta. But you know that the unit of the quantity that is calculated distance over time is speed or velocity. So if you have the graph like this, the graph of distance over time will give you the slope, will give you velocity. You draw the distance, you draw the graph of distance with time, the slope will give you velocity. So from distance time graph, you can calculate velocity. The same thing applies to velocity time graph. That is, we have your velocity like this. This velocity, this time. So if we have the graph like this, calculating the slope of the graph, theta, this will be velocity, this will be time. So if you have your tan theta to be velocity over time, so that tan theta is also your slope. The quantity that is calculated velocity over time is acceleration. Acceleration. That means from your velocity time graph, you can get acceleration of the body. So thank you. Baton.